INAH is the short form for the third interstitial nucleus of the anterior hypothalamus, and is the sexually dimorphic nucleus of humans. The INAH is significantly larger in males than females regardless of age, and larger in heterosexual males than in homosexual males and heterosexual females. Homologs of the INAH have been observed taking a direct role in sexual behavior in rhesus monkeys, sheep, and rats. Research. The term INAH, interstitial nuclei of the anterior hypothalamus, first proposed in 1989 by a group of the University of California at Los Angeles, refers to four previously undescribed cell groups of the preoptic anterior hypothalamic area, POAH, of the human brain, which is a structure that influences gonadotropin secretion, maternal behavior, and sexual behavior in several mammalian species. There are four nuclei in the POAH, INAH 1-4. One of these nuclei, INAH 3, was found to be 2.8 times larger in the male brain than in the female brain regardless of age. A study authored by Simon Levy and published in the journal Science suggests that the region is an important biological substrate with regards to sexual orientation. This article reported the INAH to be smaller on average in homosexual men than in heterosexual men, and in fact has approximately the same size in homosexual men as in heterosexual women. Further research has found that the INAH is smaller in volume in homosexual men than in heterosexual men because homosexual men have a higher neuronal packing density, the number of neurons per cubic millimeter, in the INAH than heterosexual men. There is no difference in the number or cross-sectional area of neurons in the INAH of homosexual versus heterosexual men. It has also been found that there is no effect of HIV infection on the size of INAH, that is, HIV infection cannot account for the observed difference in INAH volume between homosexual and heterosexual men. Levy noted three possibilities that could account for his findings. 1. The structural differences in INAH between homosexual and heterosexual males were present prenatally or in early life and aided in establishment of the men's sexual orientation. 2. The differences appeared postnatally as a result of the men's sexual feelings or behavior, and 3. Both the differences in INAH and sexual orientation are linked to some third confounding variable, such as a developmental event in prenatal or early life. Levy found the first possibility most probable and noted that the second possibility was unlikely in light of various homologous studies in other species. It has been proven that in rats, the sexually dimorphic nucleus of the preoptic area, SDN-POA, appears during the perinatal sensitive period as a consequence of the dependence of its constituent neurons on circulating androgen, thus offering indirect support for the first possibility. After this period, even extreme interventions, such as castration, have little effect on the size of the nucleus, which would help contradict the second possibility of behavior-changing brain structure. It has been suggested that the human INAH is the homologue of the rat's SDN-POA. Other researchers have studied correlations between INAH volume and other aspects of sexual identity. A study of transsexual individuals by neuroanatomist Dick Swab found male-to-female transsexuals to have a size and number of neurons of INAH closer to a normal female range, and that female-to-male transsexuals have a size and number of INAH neurons closer to a normal male range. This finding that the size of the INAH more closely corresponded to the gender the subject identified with rather than their biological or chromosomal gender has since been repeated, but is still controversial due to potential confounds of hormone replacement therapy.
Please subscribe and thanks for watching.